Hey there, Math 112 fans. Somebody's asking me in an email about finding C. They're asking a question about my lecture notes. I think rather than go back into my lecture notes, let's just dive into a couple homework questions. This is a quick skill you're practicing in chapter 12, and it's just a general skill in terms of doing antiderivatives. So we've talked about how when you find the antiderivative, there's no way to know what the constant is unless someone gives you additional information. In fact, we did that in class. I made up a function. I said, try to guess what my function was, but nobody could guess it because nobody knew the constant. Now in this problem, they give you a derivative. So this is marginal cost. They tell me that. And so they're telling you what the derivative of total cost is. So these are not meant to be long exercises. They're just hitting this key point. So there you go. That's the way a calculus student would write it. And here's the initial condition. They're telling you that the total cost when you plug in 100 is 25,000. And I'm double checking for units. It doesn't say it's in thousands. So that's it. There's the problem. And as we talked about in class, in this course we're just talking, using these couple basic rules how to do the antiderivatives. It's really just 4 rules. We've gone over them several times in class. So in this course, we don't do the full discussion of all integration techniques. If you want to do that, you got to take Math 125. So there's just a couple short rules, and they're direct consequences of things we've already done. Again, the goal in this course is just to sort of give you the ideas. If you at some point need to do more complicated integrals, then you got to take Math 125. Okay, that's all we need. So we are going to integrate this. We're integrating a constant. That's this one. So it's going to be 170x. And then we're going to integrate this thing. And we talked about how sums and coefficients come along for the ride, just like before. So we're just using those 2 rules. Okay. So this is 170. So this is very self-contained, even if you're confused by other things we've done. You're going to add 1 to the power. This is going to become 3/2. You're going to flip it out in front. That's what this is. We talked about how to think about this in class. 0.15 plus C. So how do you find C? So basically what the person's asking me is, do you just plug this number in here? What about if it's 0? Do you just plug it in here? In both cases, that's not the way we want to think about it. What we're saying, what this information is telling us, is that when we replace x with 100, this is what comes out. So this is telling you, replace x with 100. And you need this to come out. So you got to actually put it all in. There's no way around that. Grab that real quick. Move it up. Let's make it a little smaller. Oh, I lost a constant in my shrinking. 3. And I might at this point multiply. I have 0.3. Oh, it simplifies quite a bit. Because if I multiply times 2, it's going to be 0.3 over 3, which is just 0.1. So it actually does come out really nice. Let's do that now. This comes out to be 0.1. X to the 3/2 plus C. Now we put that information in. So when you put in 100 for X, let's do that. So there's always a moment where you have to plug in. Now there are some times when you're plugging in 0 and a lot of the things are 0 and you might be able to see what you get. But you need to plug in your values. That's how you need to be thinking. It's a common mistake I see across our calculus courses is students assuming that this is C. You actually have to compute now. So you do 1, 7, 0, 0, 0. You compute this. The square root of 100 is 10. 10 cubed is 1,000. So this is 0.1 times 1,000 plus C. And you're going to keep going until you know what C is, meaning subtract those numbers. And then the answer you're going to type in is this exact thing, but with C replaced by whatever number you find. That's what we always do. So same goes here. They give you an initial condition. This means that the cost starts at 6,200. Just because this is 0, don't assume that this is C. Don't assume this is C. You're still going to have to plug in. In fact, in this case, that's not what happened. So we'll see. Let's integrate. So total cost is the integral of 84 minus, let's move this up a little bit, 84 minus 2e to the negative 0.01x dx. This is 84x. This is 2e to the negative. So this is our other rule right here. We're going to divide by a, which is negative 0.01, which is 1/100th. So this all ends up being 84x plus 200. You can use a calculator. I'm just trying to talk about ideas. So a very common mistake here is for someone to assume that this is 6,200. That's not what it's saying. What it's saying is when you put a 0 here and here, then 6,200 should come out. It's the same idea you use when you're finding like the equation of a line. You need to use the given data and make your information fit. Now, e to the 0, I've encountered a couple students and officers that don't realize that e to the 0 is 1. That is sort of a prerequisite for the course, but if you've forgotten, all right, there we go, we can remember. So this is 200 plus c is 6,200. Let me zoom in a little bit because I'm getting into my head there. And this is going to be 6,000. And that's what you're going to type in. You're going to type in this. And that's what we were talking about when we were doing this in lecture. But I wanted to really emphasize the point that you never want to assume that this is your C. You need to plug in both of these facts, and then from that, solve for C. Now there will be times when this is all 0, in which case that is C. But don't think of it that way. Just plug in your numbers, see what happens, solve for C, and then you have your answer. Okay, hope that makes sense.